Good afternoon and welcome to our 2022 PropTech Challenge Getting to Carbon Zero afternoon session. For those that are just joining us, I'm Sandy Jackalow, co-founder of PropTech Challenge, Chief Technology Officer at Empire State Realty Trust, and a member of the REBNY Technology Committee. I just want to talk for a second about the REBNY Technology Committee. Our mission is to ensure that New York City remains on the cutting edge of global PropTech. We bring together leading investors, executive principals within the REBNY community, and we try and collaborate with vendors to find true solutions. The tech committee has several subcommittees focusing on everything from leasing, construction and development, cyber technology, as well as PropTech. Our mission and core values are education and raising awareness on key initiatives that impact real estate. We're an advocate on behalf of the industry for policies that facilitate the use of technology and drive innovation. We promote New York City and REBNY members as some of the leaders in the world. And we also do this all through collaboration between owners, tenants, vendors, and governmental agencies. And I am excited about what REBNY and PropTech Challenge have accomplished over the past 5 years. I know, as I mentioned this morning, we did start as a weekend hackathon. We ran around the clock for 48 hours and got some interesting innovation. And we realized that in 36, 48 hours, you really can't build anything. You can come up with some prototypes. And, again, that's when, Ryan Baxter and Duke Long and I realized we needed this to be time for everybody to really develop their ideas. And this afternoon, we're going to see the top finalists in 2 of our other 4 categories as we continue to deal with, decarbonization, building, improved buildings, retrofitting our buildings, and creating a better place to live and work. Again, I want to thank NYSERDA, who really has been an incredible partner. Patrick O'Shea, who is on one of our panels this morning, who really is an industry leader. They've been fabulous. I want to thank Commercial Observer for their support and partnership, both Max and Robin, who is, Robin sharing the co-hosting with me today. And as we get started in the afternoon, we're going to start with another fireside chat. So I'm going to want to bring up to the stage Paul Rode, Head of U.S. Engineering at Tishman Speyer, and Zachary Steinberg, Senior VP of Vice President at REBNY. They're going to be talking about energy storage and thinking beyond operational carbon. Energy storage systems have the potential to provide numerous benefits for building owners that really range from increased resiliency, better energy management, and ultimately reduction of emissions. What's also overlooked is, we measure, scope 1 and scope 2 emissions, and we really don't think past that. And as owners, what we need to start to do is think about the entire life cycle of our assets, from where the steel comes during the construction process to how it gets freighted over to our actual buildings, to even the refrigerant as we cool the buildings. So we're going to have, an interesting fireside chat, and then we're going to start to get into the presentation. So with that, Paul and Zachary.
Well, Paul is interesting. So why don't you tell folks here who may not know you quite so well, who you are and what you do and sort of the arc of your career?
Sure. So I'm the head of engineering for Tishman Speyer, and that job spans both new construction and property operations, and it involves looking at all the technologies, basically running the engineering teams and developing the capital and operational budgets for mostly back-of-house stuff. How I got here, interesting. I worked for Johnson Controls for a number of years doing deep energy retrofits, and that led to a few projects around the world. I was overseas a good chunk of time, and from there I went to the Related companies, had a very similar job as I do now for Related. I was Senior Vice President of Engineering, and actually picked up a lot of experience in the residential sector. Johnson gave me a lot in the industrial and commercial sectors, and then went to RXR from there. It's a very similar role, head of engineering, very progressive company that had no problem experimenting with things, which really broadened my experience base. And now I'm at Tishman Speyer. So we have about 200 million square feet. around the country. About a third of it is here in New York, but the rest of it is all over on the various continents. And in that long line, I've done a lot of these types of projects. I have to help the teams discover what, or nominate what they want to do, originate what they want to do, and then work on securing capital for it from the investor base or from our asset managers, and then getting the items in and measuring their results so that we can do more.
So you said you were in charge of deep energy retrofits, but my guess is that was before deep energy retrofits were cool. So talk about how that work has changed over the last 15 or 20 years, or however long your career has been, and then we can get into storage and carbon and things like that.
Okay, well, deep energy retrofits went from something that you couldn't find in the dictionary, and that as defined as loosely as it was impossible to deliver. So it went from that to something that did become possible to deliver due to advancements in just analytics and in material science and insulation and in just contractors getting better at performing projects that was a little bit outside their comfort zones, and designers being more accepting of technology. So it went from something that was not defined and impossible to deliver to something that was defined and probably could be delivered to something that could be delivered to now it's something that can be expected in old buildings, and new buildings are pretty much targeting energy densities that they wouldn't have targeted a few years ago. In fact, the last group that needs to be brought on board are the users of the buildings.
So you mentioned a little bit about doing projects all over the country, but Tishman Spires all over the world. So what lessons have you learned? And I guess let's maybe pivot here a little bit to thinking about storage, to projects that you've done both in the US or elsewhere, and what you think we can learn here in New York.
Okay, first of all, I would agree that, and my European colleagues would disagree with me, but I do agree that we are on the pinnacle of, here in New York, we're at the top of the practice for energy efficiency. And storage is just a derivative of that. And I will also say that what's interesting is I only speak 2 languages, but it doesn't matter where I go. There's a common language in engineers. It's too hot, it's too cold, I didn't get my work done, the chiller's breaking down. It's amazing, it's actually amazing the similarities in how the buildings are configured. They're used differently. There's more tolerances in some countries than others over environmental conditions, but they're pretty much the same stuff exists all over, at least in the Class A assets. So, and what's interesting too is I recently had had ERA prepare a list for me of all the regulations that are coming out, all the regulatory changes like Local 97 here, the Boston laws, the BEPS laws in DC, and sure enough, all over the world, this is, of course, it's following the C40 path, but all over the world, you're finding regulations being set by local municipalities on carbon standards. The challenge is global, and the usage patterns are fairly similar. So there'll be a great educational base that's built up by doing the projects. And I think that I lose nothing by practicing here and bringing it elsewhere. And I picked up some items elsewhere and brought them here.
So what do you see as, we're here at a PropTech challenge about storage, let's say. So what do you sort of see as the challenges to get solved in that space? Okay. And what are you looking for when you start to evaluate projects?
Well, all right. So, when we were introduced, I heard that, storage, helps reduce emissions. Well, yes and no, right? It reduces emissions if emissions are fairly accounted for. So, here in New York and in other cities, there's like a flat rate you apply to electric or to steam or gas for the carbon in that product, the scope 2 carbon emissions. And any type of storage uses more energy, not less, on a pure BTU basis. And so, we need to see the regulators get on board with the time of day carbon, developing time of day carbon metrics and measurements for for the utilities that we use. So given that, there's clearly, as a building operator, it is clearly better for me to have storage in a building, whether that's electric storage or thermal storage, advantaging some type of some type of phase change or just some sensible difference. It is clearly a benefit for me on the operations side. It's a little more complex to run, but it is something that keeps the teams sharper and allows us to play around with the thermal inertia in the building to basically provide a better environment at lower carbon and lower cost. And I will say something too. In the past, spanning the career, the first set of challenges 20 years ago was maintaining space temperature. Then, a decade, I can't believe I'm speaking like this, I'm this old. A decade or two after that, the challenge was you got to maintain space temperature, but you got to do it at this efficiency point, right? So that the whole conversation shifted to the efficiency point. Now it's you have to maintain space temperature at this efficiency point. And by the way, it matters where you get the energy from and how and when you use the energy. So it has to be at this carbon point also. And layer all that on top of a need in this industry to provide indoor spaces that are high performance spaces, meaning more air than in the past. Codes, 30 years ago were developed to keep people from dying in the spaces, right? Now we're pushing air into our buildings so that people can perform like they're athletes, at a World Cup event. And so that requires that much more fan energy, that much more cooling energy, heating energy, but it's a given we have to provide it, and we have to provide it at a point that, at a lower point than in the past, which means more use of storage and more use of heat reclaim and reuse.
So maybe let's shift for a second just to this category 4 conversation about embodied carbon and carbon capture, because I think one of the things you just highlighted in your remarks is we started talking about carbon in a way that we really haven't talked about before. And so, I don't know, I feel comfortable saying that I'm younger than you. I don't know how much, but even in my career, embodied carbon was not a phrase I had ever heard until, I don't know, 3 or 4 years ago. So when you think about that concept, what does it mean to you running engineering at a very large commercial owner?
Yeah, great question. And it's interesting. It's not talked about a lot. You'll hear a lot of companies come out with carbon, net carbon zero promises at some point in the future. And the reality is that they're talking about operational carbon. Embodied carbon is what carbon was expelled making your building. So it needs to be accounted for. I do account for it. I mean, we're all the time when we look at acquisitions, I do an embodied carbon calculation, compare the acquisitions. I compare the acquisitions to new buildings. I want to, I am making the argument, and we are, and Rob Spire is listening to the argument, that what we don't want to do is trade a whole bunch of embodied carbon emissions for building a new building when we could have just for an existing building that's retrofitted. So there is a tease there is a balance there, and also there is an argument to be made that there's a connection between embodied carbon and scope 3 carbon, or the activities that emit by virtue of your building being there, not just myself bringing vendors in, but the tenants. And you find that older buildings tend to be in prime locations that require less commuting. So that would go into that overall carbon calculus, where the building is, how it can be configured, how densely it can be configured. And, is there a net benefit between that and a new building? Now, most of the time there's a net benefit to a new building because you can just basically get more people in the new building, but it is not something that I do to ignore knowing what the embodied carbon is for new and old.
So how do we measure embodied carbon, and why is a new building the right thing to compare it to? Well,
and measurement, there's quick estimates that can be made on massing in a building. And they're not terribly hard, and they are very useful. The further down that that road you go in terms of trying to calculate something with NASA-like precision, the more I'll argue that the assumptions outweigh the benefit of the calculation. So I think that, you know, down and dirty, quick calculations can be done. They're relative to massing and construction type for embodied carbon, and you know, and they can be done. And you know, and then there's also a lot of sequestered carbon in the building itself at you know, something that's 40 years old. So that needs to be considered. But I mean, the calculations can be done. It gets easier every year to do them. And there's tools now that make it very simple to understand what the relative differences are.
And what do you think? I mean, I live in the world between sort of the real estate industry and the government, so I don't really know either one very well, but I sort of occupy this bizarre space in between the two of them. And I'm supposed to like talk about it like I know something, which is odd. What do you think we should do with the information about embodied carbon? Like, what does that tell policymakers or regulators, and where should that conversation lead?
Well, I mean, for new buildings, it's important to know that to force supply chains to be good about how they make things. So, I mean, there's a whole solid argument on the new building side for understanding embodied carbon and tracking it. And then in existing buildings, I mean, I think it's an important metric to estimate. It certainly should go into policy considerations. You know, there's definitely a place for it, but you know, it is what's complex is that you have to you know look at the net efficiency of the building and the amount of output the building produces from the tenants in the building. So it is important that, you know, like all buildings are not the same, and the benefit to society of all buildings is not the same. So it's important to weigh those factors out.
Well, thank you for educating me on this challenge. I think carbon capture is another one that sort of fits into this bucket in my mind, where I'm not sure we talked about it 5 years ago. I'm not sure we thought of it in the context of residential or office buildings. We thought about it in terms of like, capture emissions from a power plant or a big industrial facility. But lo and behold, in New York City, we have at least one building with using carbon capture. And you know, I'm curious about where you see that technology heading, and if you think it's applicable to a company like yours.
Well, I mean, first, it's interesting technology. It's real technology. It's been around for a while. There's different forms of capturing the carbon and bonding it and removing it. You know, one thing I weigh that question against is that you know, my first priority is electrify the buildings and let someone else worry about the carbon capture. So that's the first priority. The second priority would be, you know, buildings where I absolutely cannot electrify them because of grid constraints or capital constraints, and they have a boiler in them, and I'll do everything I can to make the boiler plant, the heating plant, as efficient as possible. And at that point, it's, you know, what do I do? Carbon capture or some sort of offset, and I'm sure that the cost, there's parity in the cost. So that's when we would look at local carbon capture. In terms of carbon capture from just air streams, I'm not sure. I'm sure there's a way of doing that. I haven't looked into that science that much yet.
So you've done some work, and I guess I have the privilege of knowing you a little bit through another hat you wear, which is your involvement in various local law implementation and working some of REBNY's committees. So do you think of carbon capture as an offset, as an avoidance, as a... It's
an offset. It's actually, there is a way to interpret the current regulations that you can, not a way, you can define it as an offset.
Okay.
And that's defined in the current legislation.
And so where do you think that, one of the things that I've heard about carbon capture is sort of, okay, well, let's prove that that carbon is really never emitted in the future once we capture it.
Yeah.
And so what do you think goes into, what have you thought through in terms of trying to solve that problem? And how would you, as a you know, real estate company, think about, well, help me prove that?
Oh, we would do due diligence, right? Where you know, how are you removing the carbon? Where's it going? Where's the ultimate destination? Just like a hazardous material, right? So we would want to know the whole chain, and we would want to buy into the accounting that is done at each step in that chain. I mean, if you're transporting something to Thailand to cast into a block, then I'm not so sure that works. But if there's some sort of logical local economy, and I hope there will be or is, then I'd be very interested in it. And the market, it's interesting too. There's a market price for that, $268 per ton of carbon equivalent, right? That's the penalty in the law, and I'm sure there'd even be a premium paid for it, because I'd much rather say that I am doing carbon capture rather than paying a penalty.
So we'll wrap up on this, but I got to moderate a panel an hour or two ago and bore all these fine people. But one of the questions I got to ask was to folks about sort of waving their magic wand and thinking about what problems PropTech could help solve. And so if you were to sort of get your say on that question, and whether it's in the energy storage or embodied carbon space, what would you like to see tackled?
Oh, I mean, first of all, there's a lot out there, and nothing is off the table. But PropTech we're trying a half a dozen things at any one time. It seems to me that all of the optimization strategies are at play in PropTech. Buildings, optimum start-stop, optimum operation of the building. Optimizing not just the building operations, but the work order management systems. The two are sort of synchronized together. There's all sorts of machine learning and artificial intelligence type analytics that can be applied to a building to help you get more out of what you're doing, identifying waste streams, limiting waste. By the way, something I will say is that our mission, it isn't so much to reduce energy in the buildings. Our mission is to reduce waste from the buildings, right? I'm actually fine with tenants using a lot of energy as long as none is wasted, because that's a measure of the economic output of the tenants, and I want to maximize their economic output, but I want to do it in such a way there's zero waste. PropTech can help in the areas that are oft forgotten, water management, optimizing use of water management, quantifying opportunities in the future, optimizing waste handling, tracking waste handling. There's, as much as I love using my iPhone and feel like I'm really high tech, I get brought down to earth every time I do a building tour. And I see 90% of the points overridden, and I just see these buildings operated at the lowest common denominator, and PropTech's it does help us get away from that.
Well, Paul, thank you, and look forward to hearing from all the finalists. So thanks.
Thank you to Paul and Zach. That was a great discussion. We're now going to see the presentation for Category 3 of the PropTech Challenge. First, I'm going to give you a bit of background on Category 3 for those of you who are not aware. It's all about energy storage. Energy storage systems have the potential to help building owners increase resiliency, improve energy management, and ultimately reduce emissions. It's very important. Category 3, we asked all contestants to use PropTech solutions to identify energy storage systems that are effective, resilient, safe, and primed to be an important component of the building's energy plans. You'll be seeing presentations from 3 panelists. Brightcore Energy, represented by David Hermiton, Vice President of Renewable Energy Heating and Cooling. Train, represented by Francesca Spinelli. She's a decarbonization specialist. And Zinc 8 Energy Solutions, represented by their CEO, Ron McDonald. Now I'll turn it over to David at Brightcore to kick off his presentations. David?
Hey, everybody. Set my timer. I'm trying to get 20 minutes into a 10-minute presentation. Well, great. Here it is. Happy to be here to present today. My company, Brightcore, provides a lot of ESG solutions. My group is the Renewable Heating and Cooling Group, but mostly what we're providing to the marketplace is turnkey geothermal solutions. So we can provide everything from the feasibility stage through construction, operation, with even options for financing, long-term PPA style financing. But here we're going to focus on our urban geo offering. Next, oh, I control this myself. Does anyone know which green button? Thanks. So first, a little bit about geothermal systems. These days, it's most common that people install closed-loop geothermal systems, which are pretty much big ground heat exchangers that are exchanging energy from the surrounding geology. This graphic here kind of illustrates how these systems operate. We like to say air source systems are really good, but ground source is better. This illustrates that during peak heating conditions in the wintertime, air source systems are getting their heat from a 25-degree source. The ground is generally about 30 degrees warmer than that. And in the summertime, air source heat pumps are rejecting heat to warm conditions outside, about 85 degrees in the summer. And conversely, well, in the wintertime, the ground is much cooler, so it's easier to dissipate heat to the ground. So there's a large mechanical advantage. So what we're bringing to the marketplace, so it's pretty innovative, is ways to install and operate geothermal systems, either for new construction or in the built environment. So the core of our innovation that we, I guess, use as a basis to describe what we're doing is a specialized drilling tool called a water hammer. This water hammer differs from what technologies generally used to install geothermal in that water is used instead of air to drive these hammers, and they use much less energy to do that. They create much less noise, much less vibration. They don't create any dust, and this allows for the installation of the systems to be done on construction sites in a much less invasive way or in retrofits. This picture actually is from an installation that our partners did in Sweden that retrofitted a building with 80 boreholes in the basement of a building. And here's a computer graphic of that design. And you may notice that this graphic is a bunch of lines, and they're angled as they extend downward. So what this represents is the surface area inside of a building where this system was installed. It was about a 14,000 square foot open area in a basement, a parking garage, where they drill downward directly vertically and also at inclined angles. This allows to capture a lot more thermal mass than could be considered before with conventional drilling technologies. So they went down from grade down to about 650 feet, and they stayed on the property. The drilling is very accurate, and we can survey it. It's generally as accurate as 1% to 2% from deviating from where our terminating points are designed to be. But today we're talking about thermal energy storage. Another inherent quality of ground source systems is their ability to, I guess, provide, I like what Paul said, thermal inertia, or kind of act as a capacitor that can buffer the loads of a building. And in a sense, this does qualify as thermal energy storage if you're using these systems to offset upcoming loads. We're really excited to have been a recipient from a grant, a generous grant from NYSERDA. The Next Gen HVAC pond had a thermal energy storage component last year, and we were picked. I think there are about 80 applicants, so we were really fortunate to get selected. This building in the graphic is the Beresford Building on Central Park West, and we're doing a geothermal retrofit inside of this building. There's a lot of talk about how systems and buildings need to be reconfigured to be able to electrify. This type of configuration is utilizing a heat recovery chiller. And this heat recovery chiller is providing heated and chilled water to fan coil units throughout the building's lobbies and offices and some other accessory spaces. What's different is what's on the load side, on the left-hand side. So on the left-hand side, you'll see geothermal wells that are circled on the lower left-hand corner of this, and an air source heat pump that's on the upper side of the graphic. And the way this system can work, the way the system is designed to work is that it's going to operate as a standard ground source system for the majority of the year. But during peak cooling conditions, it helps serve this cooling dominant area by storing up or preconditioning the loops during overnight periods. And this will provide, we're modeling an 18% reduction in energy during peak cooling. It also provides all the benefits of ground source for coefficient of performance, just very high COPs during heating. And what I like to illustrate is that during heating, this system is about 64% more efficient than an air source solution. So it's quite dramatic. The COP for a system like this hovers around 4 during the coldest days of the year. And that's it. Are we taking questions or just presenting? I don't know. A little bit of time. Yeah, I probably spoke twice as fast as I needed to. I don't know if there are any questions. All right, great. Well, glad to have the opportunity to present to everybody. Thanks.
Thank you. You guys are significantly taller than I am. Excellent. So Francesca Spinelli was unable to make it today, but my name is Erin Garrity. I work for Trane in their Digital and Energy Services group, specializing in energy storage. So we are very excited to be here today to present with you guys. And I have my colleague Tristan up here. I speak with my hands, and I only have one, so he's going to be handling the clicker performance. Excellent. So let's meet the team that made it happen. Our team of future-focused young people are scattered throughout the audience. So feel free, if you didn't get the opportunity to pick their brains at lunch, I highly encourage you to do so. Like I mentioned, my name is Erin Garrity. I do Digital and Energy Services for Trane New York, specializing in energy storage. This afternoon, we are going to do a brief overview of traditional thermal energy storage systems. Then we're going to watch a case study from one of our early adopter partners. Then we're going to get into the very exciting topic of how Trane has reimagined thermal energy storage systems to align with decarbonization goals with the electrification of heat. A recent study by UC Davis states that thermal energy storage systems are up to 77% more valuable for the grid than previously estimated. And I'm sure that we're all so excited to hear that the research is finally backing up what we've known for a very long time. Thermal energy storage solutions offer reliability, scalability, integrability, and they're proven effective in New York City buildings where space and electric costs are both at a premium. Thermal energy storage solutions also offer the opportunity for building owners to take advantage now without having to wait for policy changes that may be associated with other storage technologies. One of our partners at SL Green 11 Madison installed a thermal storage system, so here we're going to watch a video.
If you think about cities, first off, buildings themselves represent 76% of the electricity consumption of the world. And so cities have a big strain on the environment.
Energy and emission standards for the city and state really matter. We all have to take a serious look at reducing our footprint. These types of decisions are at the vanguard of our commitment to SL Green's environmental, social, and governance program.
In New York City, the power usage has changed dramatically and will continue to change dramatically. Con Edison, as the provider of all this energy, we need to try to look ahead and plan for the future.
Trane, as a company, we set bold targets for sustainability.
Con Edison is asking the community of New York to participate in demand reduction projects. And so thermal storage is a key component of the program that's being offered.
In this city, the peak load is the air conditioning load in the middle of July. And thermal storage is focused right on that. I mean, you cannot find a better solution to reduce that peak than thermal storage.
Our vision for 11 Madison will ensure the building's legacy upholds its reputation for excellence in offering premier office space supported by modern infrastructure.
Air conditioning accounts for about 40% of a building's energy use. So for 11 Madison, one of the most iconic facilities in New York City, a thermal storage system really made sense not only for their bottom line, but also for their sustainability goals as a portfolio. The thermal battery cooling system acts as battery, charging the ice bank energy storage tanks when excess or inexpensive energy is available, and discharging when demand is high or price is high, or when the utility asks for the discharge to occur. We're creating ice at night, and we're using that ice during the day to cool off the building. We are reducing the amount of energy required by power plants that are stationed in our area.
We thought long and hard about the ice plant project. When we made this decision, the timing to switch out existing equipment with new, energy-efficient technology was perfect.
At 11 Madison, we brought in all the equipment. Every night we'd come in, remove all the protection, bring tanks in, lower them down into the 4th basement. It's a lot with the fully occupied building.
It was a learning experience for everybody. And train came in, we had multiple training sessions, and it really taught us a lot about the system and how to tweak it.
We'll sit with the operators, we'll sit with the management so they understand how the system works.
We were able to accomplish our goal from start to finish in only 5 weeks. So that's a huge testament to the train team and to SL Green's team.
One of the keys to a successful project like this is data and information that allow us to, from a distance, track to see how a building's doing.
Without that data, we would not have been able to communicate a compelling story to show the performance of the system that's being installed.
With the ice plant, we were able to lower tenant energy costs by 10% and decrease our carbon emissions. We were able to prove out to our tenants that there are financial gains by making capital investments into the base building. SL Green capitalizes on every opportunity we have to green our portfolio because we have a responsibility to our tenants, our partners, and to New York City as a whole.
Everything that we do is focused on how do we reduce greenhouse gas emissions for our customers. The Energy Efficiency Leadership Award recognizes customers that have a large impact on CO2 reduction for the climate, and SL Green fit that perfectly this year.
Having Train as a strategic partner, we knew it would be a success. Our project at 11 Madison was our maiden voyage with Train. We've asked them to now partner up with us at 220 East 42nd Street. They're joining us at 1 Vanderbilt, our marquee development site. The future opportunities with Train seem endless. And as we move towards a more sustainable future, I can't see us doing it without Train.
Electrification will likely play a part in a low-carbon future, so understanding heat pumps and thermal energy storage's relationship to them is going to be critical. I know that the panel up here pre-lunch spoke on some of the challenges that we're going to face, so we've come to the very exciting part of our presentation. Enter Train storage source heat pumps, a reimagined approach to thermal storage that addresses several prominent challenges on our road to electrification, including thermal balancing, physical space requirements, low ambient performance, and lowering upfront costs. The versatility of our solution captures the essence of strategic decarbonization in one of the world's most prominent real estate markets. Train's storage source heat pumps solution utilizes the same system assets in different configurations based on ambient temperatures. And for questions that are more technical based, I'm going to defer to my teammate, Patrick McBride, who's waving his hand. He's our systems expert, so anything design, you guys can go to him. He's our expert. And with that, I would like to take the opportunity to thank REBNY and NYSERDA and all our other partners. This was Train's second PropTech Challenge that we participated in. It's probably the highlight of our year. We love to get together and challenge ourselves to come up with new technologies. So thank you for the opportunity, everybody. Thank you.
Well, good afternoon, everybody. My name is Ron McDonald. I'm President and CEO of Zinc 8 Energy Solutions. Let's see if I got a solution here to turn this. It's the green button, right? Okay. First of all, I want to give you a little background on our company. We've been around for probably 12 years, 10 to 12 years in our present iteration. We started off when I took over the company, we had about 13 employees, about 2 years ago. We now have 56, and we're aggressively pursuing our first production facility in the state of New York. So it was good timing when we got this notice, because I was coming down to the state to look at sites for our first full production facility, which would create about 400 to 600 green jobs in New York State. New York State made us a company. When I first took over this company, we weren't well known. Zinc Air Technologies had troubles all through its development with the production of dendrites. And the dendrites would stick to the plates, it reduced the efficiency, all that stuff. I've got a really smart team. So the smart team took over and said, what we need to do is to make those dendrites work for us. And they developed a completely different system. Let's see if I can move this one. Which button, guys? Green, red? Green. That green? Not moving. Green. There. So we developed a completely different system that looked, instead of fighting the dendrites, we said, we'll make those things our friends. Over a number of years, they created a system. This is it here, which is a component system. You can see there's 3 different parts of it. So the first part is zinc regenerator, and we generate zinc particles and we charge them. We don't really care. We're agnostic about the source of the power, although the system really, really encourages incorporating a resilient, renewable power resource. So once we do that, and then we store it in our storage tank, and then when you need the power, we put it over to the power stack. Now, what's unique about us? We have decoupled energy and power. So most of the systems that you would be aware of, like say a lithium ion, they haven't decoupled the energy and power. So it's a 1-to-1 ratio. So if you got 20 kilowatts of power, you can only store 20 kilowatts of energy. If you want to double the amount of energy you store, you have to double the amount of power stacks that you have, even though you probably don't need the power. We can independently scale here. So if you want more, if you want more zinc generated, we have the zinc regenerator, we upscale it. If you want to store more power, we just add a bigger tank. And if you need to have more power on the output, we put more power stacks in. So it makes us very customizable at very little additional cost. We're low cost, abundant materials. This is a big thing right now. And I used to say this in the last couple of years of running the company. Right now, the world is stressed with supply chain issues. And all we have to do is look on the TV today, and you can see what's happening over in Russia. Russia controls about 32% of all the nickel that's produced that goes into some of the technologies for storage. Or you look at China, which has been very aggressive over in the supply chain side. We don't have anything in this battery that cannot be sourced within the United States. So you've heard from the governments that they're talking about supply chain issues, particularly over on the renewable sector and the storage sector. We don't have that issue. We're one of the few battery technologies. Everything that's in our battery can be sourced in the United States. And our system is, as I said, modular and scalable. A couple of technology advantages. The first one is that we're durable. Anybody that's got a phone here today or a laptop, you know that the first charge that you put on that is the best charge you're ever going to get. It starts ghosting after that. So your full charge in 2 years down the road gives you half the time that you can use the device. We have 0 ghosting in our system. So in our system, the first charge and the last charge, 20 years later, is at the same strength. Low cost. The longer the duration requirements, the lower the cost gets. And you'll see that in my next slide. And that, again, is one of the unique advantages of the technology that we've got. And sustainable growth. All of our supply chains for mass manufacturing can be sourced within the United States, or indeed most countries in the world. I just want to look at this one for a second because it deals with some of the supply chain issues that are really affecting the world today. So when you look at our competition, if you look at vanadium flow batteries, it's an exceptional technology. But once they get to a certain point, the excessive cost of the electrolyte, which can be 70% of the battery, flatlines them. So you can see that probably at 8 hours, they're at about $450 per kilowatt hour of storage, but they only go down slightly as the amount of storage required by, say, a building goes up. And it's the same with lithium ion. Lithium ion, if you look at lithium itself, lithium prices have gone up about, I think, Mark, from 10,000 to about 700% in the last 12 months. That's a lot of increase. If you go over to something like zinc, zinc has gone up 44% over the last 12 months. So the commodity that we use to do the storage has been very, very stable, and it gives us a big cost advantage. We used to say that we can beat anybody at cost at 8 hours of storage because we're long duration storage. That has now slipped. We can beat anybody at 5 hours because of the increasing commodity prices for some of our competitors. But this price line will show you why we've had the interest from people like NYSERDA and NYPA and Con Ed. And it's because the greater the amount of storage that's required in an application, the cost per kilowatt hour goes down substantially. So at this point in time, we can't find any competitor in the long duration storage hours, say 8 to 100 hours, and now 5 to 100 hours, that can deliver this cost curve to the consumer. Now, this one here is a bit hard to read, and I wasn't sure I was going to use it, but these are solutions for New York buildings. Go look at it over here. So a couple of them deal with peak management, demand reduction. That's peak shaving. So trying to take the power where the cost is the highest and to shift the load to the lowest cost power. So our energy storage system can take the lower cost power at night, and we can use that to supplement the higher cost power through the day. Where there are demand charges, and different jurisdictions have different demand charges, we can design a system specific to the application so that you never get that demand charge again. Interestingly enough, in a place like New York City, power can be, you're all consumers, over 30 cents a kilowatt during the day, and at nighttime, it can go down to about 5 cents. So we can take large amounts of that 5-cent power at night, store it, and for you to be able to use it and significantly reduce your costs through the daytime. Bill management, backup power. Backup power is extremely important, and we've all seen that after Superstorm Sandy and the cost to the economy just here in New York when power is lost for days at a time. We can provide multi-day storage. We can build that system for you. Energy arbitrage, frequency regulation, voltage support, and curtailment avoidance. So one of the things that our system provides is a customized operation for any building in New York. Local Law 97 was pretty important to us because it set out a series of requirements for buildings in New York to decarbonize. But we've had great success in New York State. We've also had it in New York City. So I'm just going to highlight on a couple of projects that we're doing. One that we announced a little while back was with Fresh Meadows in Queens. It's in the engineering design stage. It's a 100 kilowatt, 1.5 megawatt hour, 15-hour duration project. And our collaborators are Digital Energy Group that's built out over 130 cogens stations in New England, mostly in New York, CHP plants. And with support from NYSERDA. NYSERDA has supported this with over $600,000 for this demonstration, and we want to thank them for it and for taking us under the wing and helping us understand the opportunities in New York. Last 2 years ago, we were the winners of New York City's Department of Buildings Innovation Challenge. And everybody knows the Department of Buildings regulates over 1 million buildings in New York. And with the requirement that any building over 25,000 square foot has got to reduce its carbon footprint, means that there's 60,000 buildings that are in that category. And with our company, we were developing a 50 kilowatt system, which is ideally suited for that particular market. And we will be coming on stream with that product in 2023. So we get a lot of government support over in New York. We're also looking at the University of Buffalo. This is with NYPA. A couple of years ago, we entered a challenge with NYPA to do non-lithium 6-hour and above storage. We gave them a 10-hour solution. There was 102 competitors, and after 9 months, we were the last man standing on this, or woman standing on this one, from a corporate perspective. And then we partnered with them with the University of Buffalo, and we are providing a solution for them to provide backup power for their entire northern campus. And that's important to us as well, because they're the leaders with New York University, with SUNY, and they're the leaders in over 62 campuses in sustainability. We also won another contest here, and it was Scale for Climate Tech, which took us under their wing in New York and helped us to de-risk our manufacturing process, which we're just about to start in the state. We've also been really lucky. We were over with New York State, the Urban Institute. We were the first non-US company that was taken in there. We were the first company that was already listed on a market, and they have been instrumental in us being able to move our product forward. So I guess I just want to finalize this by saying that we're one of those we are a New York success story from Vancouver and from Toronto. And the technology was originally developed in the West Coast of Canada, but New York State and New York City has given us the opportunity to commercialize and to draw the attention. So in conclusion, I would say that Zinc 8 Energy Solutions is your new New York partner for compliance with Local Law 97 and to increase the energy economics of buildings in New York. We've also produced a service, an opportunity for buildings to have storage as a service. So instead of all of the purchase and build and owning it for the building owner, we've got a unique product that we'll be announcing in more detail in the coming months, where we would be providing storage as a service, where our company would build, own, and operate, provide the cost savings on the load shifting that would be required, and any carbon credits that would be gained, we would share with the building owners. So that is an exciting business venture for us. So thank you for New York for allowing us to come down, New York City, and present to this group. Thank you.
So those are some great, interesting presentations in category 3. Now we're going to move over to category 4, which is embodied carbon and carbon capture. This is a growing focus where owners need to measure beyond scope 1 emissions, which are direct emissions from equipment like boilers and furnaces in our building, and level 2 or scope 2 emissions, which are indirect from the generation of things like purchased electricity, steam, and cooling. As an industry, we really need to start to think about the total emissions impact of our buildings. That means taking into account refrigerants, the materials of our building, as I said earlier, the emissions from building, steel and creating steel, and all the other things from delivery and transportation. So this is a new area so that we can really understand the total footprint of carbon in our building and the steps that we need to take to reduce those through the entire life cycle, which would include the disposition of the property and the asset. So with that, our 3 finalists, we're going to start off with Brian Esparrow, COO of Carbon Quest.
Thanks, Andy. Hi, I'm Brian Esparrow, and I'm the Chief Operating Officer for Carbon Quest. And we are in the embodied carbon and carbon capture category. But actually, how we got to that is a previous company that we started called Demand Energy that was focused on energy storage. And so in New York, we developed a significant amount of battery storage properties here in the city, including what we believe is still the largest energy storage system in Brooklyn at the Gateway Mall. But what we saw is that there was a big push towards building decarbonization. And so our mission is to provide immediate economic pathway to help buildings achieve carbon reduction and decarbonization within the built environment. When we looked at it from a building emission standpoint, we started seeing 1,000+ cities. We've talked about all day today, 1,000+ cities with carbon reduction targets. Within cities, buildings typically comprise 60 to 80% of all emissions. Here in New York, it's about 67%. Gas infrastructure in particular is what we'll tackle and discuss, is a big issue in terms of how to decarbonize. We talked about electrification. We would like to incorporate here, what we're doing here is building carbon capture and also affecting embodied carbon. There's also a bit of the discussion around reporting and all the data that's going into Scope 1 and Scope 2 reporting for SEC and beyond. A lot of these groups and all these pieces of information here come together to look at the problem that we're trying to tackle. The problem that we're trying to tackle is natural gas use in buildings. And so it's a significant amount of gas that's being used in buildings around the country. Here's a few numbers here, but 54% of multifamily buildings in 2/3 of the country use natural gas for heating. What are they going to do? We'd like to think that there's not a one-size-fits-all problem or solution, but the solution that we're bringing into this is carbon capture. So in particular in New York, as we've been discussing all day, the city, natural gas consumed in buildings is about 17 million out of the 50 million tons that the city emits per year. So how are we going to solve that particular problem? A lot of the solutions today were discussed on how to solve that. 30,000 buildings larger than 25,000 square feet use natural gas and are subject to local law 97. 37,500 buildings will be out of compliance, and the market is much larger. So as you can see in that red circle there, that's that portion of buildings that are still using natural gas. How are we going to decarbonize that? Well, we developed an approach, what we call building carbon capture. We spent some time, we hired some smart people, we looked at how would be the most effective way to fit a system into a building to capture flue gas. It's a 4-step process. So on the left-hand side, you see boilers. It's essentially any stack. So if you think about a cogeneration stack, a boiler stack, typically flue gas would go out, the gas would go out the flue and up the chimney. That would be an emission. What we're doing here is we're avoiding that emission from going out the stack. In this 4-step process, we first condense that gas, we separate and purify that gas, which ultimately comes into effectively 100% pure carbon dioxide. We liquefy it and we have it on site. So that's carbon capture. What are we doing in terms of the embodied carbon part of this? Well, we sell that CO2 locally to a concrete manufacturer that is now utilizing technologies, there's several of them on the market, to utilize CO2 to create calcium carbonate, thereby sequestering that CO2. So what this process ultimately does is it avoids emissions from going out the stack, therefore reducing emissions for a building. What is the value proposition? So in this case, we really have two customers. One is a building owner, the other is a user of CO2. So for a building owner, it's immediate decarbonization, immediate reduction of carbon, not having to wait for the grid to green, not having to wait to outfit a building to electrify. You can consider it a bridge if that's what's to electrification. You can consider it a problem to solve in hard to abate areas, but it's immediate decarbonization. It's cost effective. Right now, we're looking at anywhere between a 4 to 6 year payback on the capital cost, and in some cases, it's a bit lower. Non-disruptive to operations. These systems typically fit in a room, a few hundred square feet, depending upon the size of a building. We're not rewiring a building. We're not changing the operations of a building significantly. Typically located somewhere around or near a stack or near a boiler room or cogeneration room. We measure and report the emissions. So we're tracking exactly how much emissions we're reducing, and then we're improving the E and the ESG, which I think we're all here for anyway today in terms of carbon net zero. For a CO2 user, like a concrete block manufacturer, or for a utility that may use CO2 for reducing emissions, it's lower carbon footprint than most competitors, where CO2 is combusted, in many cases at an ethanol ammonia plant, and then shipped all the way from the Midwest or the South or upstate New York to New York City. It's local. So right now we are capturing CO2 at a multifamily property in the Upper West Side, and we're shipping it to Brooklyn. Much easier than shipping it hundreds of miles. And we have competitive pricing. So this is the first project that we are now operating. It's a multifamily site across from Lincoln Center. And the main objective here was to reduce emissions and then ultimately reduce potential exposure to local law 97. What we're doing is we're reducing about 50% of the natural gas emissions. That's 700 tons of CO2 per year. So it's significant, right? There's a 5-year payback, and it's not very disruptive to their operations. We're now out and building several more. So we just think this is a tool in the overall carbon net zero landscape. This isn't the only solution, but it's a pretty significant one for buildings that use natural gas. Where will it work? Virtually anywhere there's a stack, effectively, meaning a stack or a chimney. It works with all types of buildings, whether it's multifamily, whether it's commercial office, industrial, schools. It's great application for boiler operations, boiler plus absorptive chillers that are using natural gas for cooling, cogeneration, and combined heat and power. Flexible location. So this is a picture from our first system. And it can be located in basements, parking garages. There are outdoor applications that we have designed, as well as potential setbacks as well. Let's kind of think of it as a similar situation to cogeneration or a boiler plant. Certainly trying to locate these in buildings is not an easy feat, but it's not impossible either. We talked a little bit about the benefits. In this case, we're primarily using this tool here in New York to reduce emissions as it relates to local law 97. For those buildings that do not have exposure to local law 97 or are looking to reduce emissions and are not under a current regime, we can sell these emissions reductions into the voluntary carbon credit markets. It will create a similar style of reduction in terms of the economics for a proposal like this. The capital cost will vary by the size of the building, so it's a modular-based system. And ultimately, we feel that this is an opportunity that will certainly scale and expand. These are just 2 last examples of, what could this look like? So a multifamily building, if you're familiar with the building exchange, it houses a lot of information on buildings through local law 84 that calculates the local law 97 penalties. And so for a building that is a multifamily building with boilers that has a significant penalty, $700,000 starting in 2024, this is the type of solution where carbon capture can work. But it could also be combined with energy efficiency, on-site solar, thermal storage, and the like. Similarly, commercial office building with cogeneration. This type of system could work very well in this case, and we are talking, in fact, with a number of building owners that use cogeneration now as it solves a problem as its base load type of power. Finally, we thank REBNY and all the partners for putting this on. This is our first time here. We appreciate the opportunity. We'd love to speak with any property owners, anybody in the industry. We think that this is, to get to net zero, is not going to be one company or one solution that does it. And we just are trying to institute one possibility of doing so. Thank you.
Next up, we have Tom Scott, Founding Director of Construction Carbon.
Thank you, Sandy. Here we are. First, thank you very much indeed to REBNY and to NYSERDA for having us here. It's a great privilege to be here. I'm Tom Scott, Founding Director of Construction Carbon. Embodied carbon, as we've touched on, carbon emissions associated with construction. Upfront embodied carbon is the associated carbon with the construction process, getting to the point where your building is ready to inhabit. We are not at a point where we are measuring construction carbon. For various reasons, we're closely looking at carbon from an operating perspective. Until we start to focus on mitigating construction carbon, there doesn't seem to be much reason for us to measure it. This was a quote from the president of a major New York real estate development company to us just this week. And there's every chance that you feel like this as well. But when it comes to new buildings, upfront embodied carbon is responsible for up to 50% of all of the carbon emissions across that building's lifetime. 50%. Put that another way, once you've completed a construction and you hand the keys over to the new tenant or a new owner, up to half of the carbon emissions that building will ever produce have already been emitted. So, where do your constructions or the projects you're involved with, where do they fit on a scale like this? In terms of, really good carbon emissions from construction to really bad. There's every chance that you have no idea. Paul mentioned that he's doing this already, which is great news. Perhaps you don't feel that you need to at this point, but really, it's important that you start to understand where you are. Why? Because legislation is coming. The panelists before lunch mentioned this, and Paul touched on it as well. Legislation is not going backwards. We're looking at operating carbon, but carbon emissions from the construction process will be legislated for. How will this affect you? Well, finance will be harder to achieve and to find at competitive levels. But development finance might be cheaper if you can demonstrate that what you're building is more sustainable. Build costs are likely to increase because you're going to have to incorporate more carbon efficient construction techniques. Offsetting is the net in net zero. So at this point, you're going to start to consider, or you have to start to consider, what the costs of those carbon offsets are likely to be. Construction carbon is an independent construction carbon scoring platform and verification process. We have produced an accessible means for anyone undertaking a construction project to assess, reduce, offset, and publicize the carbon emissions associated with their construction. We're driving consistency in the assessment and reporting, meaning that when it comes to looking at carbon emissions from across the construction industry, confidence can be gained by developers, by funders, by consumers, and by local governments that construction projects can be compared on a like-for-like basis, that you can compare apples with apples. And we also mean that those people undertaking construction projects can't be accused of marking their own homework. Assess, reduce, offset, report. The classic route to net zero. However, you don't need to go from 0 to 100 miles an hour straight away. The first step in addressing carbon emissions from construction or anything is understanding them. As has been said, you can't manage what you can't measure or you don't measure. So how can you start? Well, through our accessible platform, you can first get an estimation. With a few clicks of the mouse, you can start to understand at a high level what the major contributors are to the carbon emissions from your construction projects. Secondly, formal assessment. This is a deep dive into the construction materials and processes in 2 stages. The first stage, notional, at the as-designed stage, to inform better decisions throughout construction. And then at the as-built, there's an actual assessment. Carbon reduction strategies are produced, and 4, you can acquire credible offsets that meet international standards that neutralize the carbon footprint of your construction project. Our platform is accessible and financially attainable to anyone undertaking a construction project, from contractors undertaking 3,000 square foot commercial refits to developers building 1.5 million square foot logistics centers for Amazon. The developer of this building came to us and said, embodied carbon emissions. The carbon emissions associated with our construction. We know that we're going to have to start dealing with this, but we do not know where to start. This construction in northern Italy was well underway. Nonetheless, the developer wanted to understand what the carbon impact of that building was. And they also wanted to understand what strategies they could put in place to reduce the carbon impact of future developments. We worked with their existing team. We ensured that a life cycle carbon assessment was undertaken and that it was peer reviewed. The results were produced in a clear report that broke down what the carbon contributors were and provided more carbon efficient alternatives. In this instance, at the point of completion, the developer asked us on their behalf to oversee the acquisition of several $100,000 worth of carbon offsets so we could verify that at the point of completion, the building was carbon neutral for construction. Transparency was key. This development, as with all of our developments, were publicized on a dedicated web page. The assessments, the reports, the offsets, and the verification, all available for the public to see. The carbon neutrality of that building formed a major part of the marketing. The building remains the most valuable logistics building ever to sell in Italy, selling for a sub 4% yield. Our process removes the complexities of understanding the carbon impact of your development projects. All you need to do is send us your development information and we will do the rest. You don't need to understand who the best consultants are, who the most suitable consultants are. You don't need to negotiate the scope of works that they undertake for them and to negotiate heads of terms. You don't need to understand what the most recent legislation is and what the most recent guidance is. Construction Carbon does all of this for you. We provide you with an independent, peer-reviewed lifecycle carbon assessment. We identify carbon hotspots, and we provide more carbon-efficient alternatives for consideration for future projects. REBNY is the city's leading real estate trade association. Founded in 1896, it is also the first. REBNY and its members are trailblazers, and here you have the opportunity to drive forward the decarbonisation of the construction industry in New York. This has to be a team effort. Several of the previous speakers have said the same. It requires a team effort to develop the benchmarks and to drive forward the better building practices that will lead to the decarbonisation of construction. This PropTech challenge really resonated with us because while at the heart of it, the focus is to establish solutions that meet the needs of the New York real estate industry, it also sets out its ambitions to break down geographical boundaries and to develop global networks and global relationships. Based in the UK, we're working with leading experts from across the world, from UK to Australia, Singapore, New Zealand, Hong Kong, and here in the United States, we're talking with the Carbon Leadership Forum. Carbon is not a local problem, it's a global problem. And we have assembled a global team to help you. Thank you. There are some rather tedious demonstrations here, but I think I'm out of time and you'll probably thank me for that.
All right, thank you, sir. And last up, we actually will have one presentation virtually. Petri Laxko, CEO of Soltaire Power.
Yes, I can. Can you hear me?
Can you hear us? We're ready for you. You're on center stage.
Yeah, thanks. I hear you loud and clear. Can you hear me? Yeah, okay. Can I see the slides? So it would be slightly easier to present, but otherwise we can go. Okay, so I'm not seeing the slides. Just a sec, I will take it on the other screen for myself so I can kind of follow in. Sorry about that. Yeah, I'll put the. All right. Thanks for selecting us as an finalist here. And so we are Solitaire Power. I'm Petri Laakso, the CEO at the company. So we want to convert buildings into CO2 capturing machines. We do that by capturing CO2 from building ventilation so that we can make people perform better. And also we can turn the captured CO2 into something useful like fuels or turn it into concrete, and so on. Next slide, please. Company is founded in 2016. There are 17 employees at the moment. We are based here in Finland, Lappeenranta. And so we contribute to reducing emissions in buildings by capturing carbon from the ventilation system. Next slide, please. Everybody knows that the CO2 level in the atmosphere is getting higher and higher, and that's why we think that there needs to be negative emissions, so that you need to remove the CO2 from the air, not just by limiting a smokestack. Of course, it's a good way to kind of slow down the climate change, but we think that you should do negative emissions. And by doing that, you can really turn the course of climate change. And next slide, please. If we look at how the CO2 affects us people, it affects the nature, but it also affects us people. And here's one study from US, that if the outdoor CO2 level doubles to 800 ppm, which easily happens in buildings and offices, we will lose like 20% of our cognitive function. And since we spend most of our time in buildings, we think that the CO2 level lowering in buildings would be a good thing for people performance. Next slide, please. So we do this in buildings and in building ventilation. And if customer wants, we can turn that CO2 into fuels like we did in the Dubai World Expo this year. And this way we can increase people performance, do those negative emissions in buildings. So we can really make a building act as a carbon sink in let's say, net way. And yes, next slide, please. Here we can see an installation. On left, there is the metallic looking box is the ventilation machine close by a building here in Finland. And on the lower left side, the air is entering the ventilation system, and it doesn't matter what is the temperature outside, whether it's +40 or -50 or something. After the ventilation unit, it's typically 20 plus something, and it's really good for the carbon capture and before the air goes into the building. On the top side of the picture, we can see an exhaust pipe or duct from which the air escapes the building. If you capture the CO2 from that duct, you can maximize the CO2 capture, but you don't do the people benefit. If you do the recirculation channel CO2 capture, then you can do both in the same building. Next slide, please. If you have a single room system, what we can also offer, you can really keep the CO2 levels low. Here is one example from a single meeting room. This is from a building which was built 2006, so fairly modern. So we can really keep it like below 600 ppm, even though without the system, even though the ventilation is running, it would go to 1,200. So this is really a big difference, and you can really feel the change if you have a system at your office. Next slide, please. Of course, the reporting is a vital part of our business, because the customers want to know that is the system running, because the service is kind of in the air. And when they are running the system, so we can report how many kilos of CO2 was kind of captured from the air and how it affects the indoor air. Next slide, please. If you take a big city like Tokyo, if you make a really wide-scale deployment of our technology from all the commercial real estate in Tokyo, we can capture like 6.5 million tons of CO2 per day from the ventilation that is already running. So it makes really a difference. And it's our normal, if you take it from a normal ventilation, you can capture as much of CO2, or which is equal to half of the building's CO2 emissions in the operational lifetime. And we can sell this as a service or as an investment to the building. Next slide, please. Some details about the one ventilation unit, or let's say here is 5 ventilation units. So if you put it in a building, typically one unit is like close to 20,000 square foot. And if you have 5 of those, you can capture like 6,000 kilos of CO2 or 5,500 in 1 month, which is equal to 6 acres of forest in 1 year, sequestrating carbon. Next slide, please. So those 2 business models. First one is, of course, investment. Since we are a startup, it's easier for us to just sell the units. But then the next is that we can sell this as a service, so that the building tenants can take an advantage on the best indoor air for their employees. The cost is like $1 to $2 a day per employee. Next slide, please. There are, of course, other companies capturing carbon or CO2 directly from air, but they are mainly focusing on outdoor large-scale capture, and we are doing this in buildings. Next slide, please. 4 different product categories. First one, the building HVAC connected device. Second one is the outdoor CO2 capture. Third one is the single room problem solver, and the fourth one is the power to X unit that you can really capture CO2 and make fuels out of that. Next slide, please. So we have 7 patents. This one was granted to us in December last year in US. Next slide, please. A huge market, completely new one though, but there's a lot of real estate out there that we can make like a system that is used in every building in the future when the CO2 level is higher. Next one, please. So there's some traction that we've made over the years, and several deliveries. Latest one to Germany. Next one is going to Danish customer, and last year we had a delivery in Dubai. Next slide, please. Team has a really long experience from different startups. Biggest exit 120 million to Visedo, to Danfoss, and we think that we are the best team to make it happen. Next slide, please. So what we are now looking for is a Series A funding, and for this we can get a 24-month runway to work on the CO2 capture solution for buildings. Next slide, please. So thank you. I guess I used my time already.
So on behalf of the Commercial Observer, I want to thank everyone. Wonderful program. Look out for tomorrow's full extended coverage on commercialobserver.com from the program and all of the various sessions on social as well. We're going to be launching a new ESG newsletter with a focus on carbon starting in June, so look out for that as well. Feel free to contact me. I'll connect you with our wonderful editorial team as well. I'll be circulating an email with my contact information. So on behalf of the Commercial Observer, thank you all for coming. Those tuning in, thank you as well. And pass it along to Sandy.
Thank you, Robin. Thank you, Robin, for being such a great co-host and Commercial Observer for everything you've done over the past several months and raising the awareness and the digital presence. So thank you ever so much. I want to thank the team at NYSERDA again, who have been fabulous. We also had sponsors in Brookfield Properties and the Durst organization, so I want to thank them for supporting this and also helping to make this happen. The folks here at Convene, and again, thank you, AV staff. You've been absolutely fabulous, so thank you very much. And most of all, I also want to thank the entire REBNY team, particularly David Mock and Chris Beach. Sam, the marketing team, they've all been a pleasure to work with. The technology committee under John Gilbert's leadership that helped really support this and drive this through, and all the judges who had to literally go through anywhere from 10 to 30 to 60 videos and presentations, which again, a lot of this stuff is all going to be on our website. So thank you all. Thank you folks on Zoom. Thank you to folks here. I have one parting announcement. As we talk about all this data going back and forth regarding sustainability and carbon measurements, one of the things that we have to focus on is cybersecurity. And the REBNY Tech Committee has a cyber subcommittee. And coming this June, we are launching some best practices and cyber standards that'll focus on OT, the operational side. So be on the lookout for those, because as we capture data, we have to protect it, because it's our proprietary information, it's our trade secrets, and we have to protect our buildings, our residents, our tenants, and our companies. So coming soon, cybersecurity standards. So you will be hearing from me again on that. And again, thank you all. I hope this was as informative and educational as we raise awareness to getting us to carbon zero. So thank you all.